In problem number 5, we want to find the volume of the solid generated by revolving the region bounded by y equals x squared, which I graphed as the red parabola, x equals 0, which is the y-axis, and y equals 4. And I did add here that we want that region in quadrant 1 because that is a little bit ambiguous. But we are rotating it about the line x equals 5, which I graphed in that kind of light blue color. So I already created my graph here just for the sake of time on this video, but the next thing that I'm going to do is I'm going to show what my solid would look like when I spin that around the line x equals 5. So obviously we're going to have like a mirror of that area shape over the line x equals 5. And so we're going to have something very kind of strange looking, right? And if you spin it around, you know, these pieces here on the edges are going to be like solid, and there's going to be this kind of volcano-shaped looking hole in the middle. And if you cut out chunks here, they're definitely going to be like washer shaped. Okay, so that's kind of what our solid of revolution is going to look like. And so if we were to slice off a cross section of that, we already know that it's going to be a washer. And the radius of our outer, if we look at the outer, right, the outer radius here is going to be our 5 minus 0, because basically that's, you know, the line that we are spinning this around, right? So again, I guess I should go back and I should say, remember that if we are spinning this about the line x equals 5, that we want to integrate with respect to y. So maybe let's go back to that for a second. Okay, so when I think about my outer radius here, when I look at the picture that I drew, and if I maybe look at the disk in its solid volume form here, that's my outer radius, right? That's my distance from here to here. And so that is 5 minus 0, if we want to think of it, because remember, when we are spinning around an axis that isn't the x-axis or the y-axis, our radiuses, our radii are always going to be the axis of rotation minus the function. Okay, so this radius here is just going to be 5, or if you want to think of it as 5 minus 0, we can think of that outer radius as being 5 minus 0. And then our inner radius, which is just, you know, from there to there, that's going to be 5 minus our function. Remember, our function is y equals x squared. So again, y equals x squared, if I want that to be x equal, that's going to, I'm going to have to square root both sides, so that's going to be x equals the square root of y. And if I have to do the axis of rotation minus the function, then the inner radius here is going to be 5 minus the square root of y. That is quite tricky. All right, but once we have that figured out, we can go ahead and set up our area, or I should say our volume integral. So our volume, again, is going to be equal to the area of the outer minus the area of the inner. Now, our limits of integration, because we're integrating with respect to y, if we look at our original picture and we look at where our y equals x squared lives that we're rotating, this point right here is 0, 0, and this point right here is 2, 4, right? But if we are integrating with respect to y, then we are interested in the y values of those ordered pairs for our limits of integration. So our limits of integration are going to be from 0 to 4. And then, again, it's going to be the area of the outer minus the area of the inner dy. And so my area of my outer is going to be pi times my 5 minus 0 squared. And my area, my inner, is going to be pi times 5 minus the square root of y squared. So this is kind of a messy one. All right, so I'm going to factor out my pi and pull that out in front of the integral first. 5 minus 0 is just 5, and 5 squared is 25. And then I'm going to FOIL the 5 minus the square root of y squared. So that's 5 minus the square root of y times 5 minus the square root of y. So when I FOIL that, I'm going to end up with 25 minus 10 square roots of y, and then negative square root of y times negative square root of y is just positive y dy. And then, of course, I need to distribute the negative to that trinomial. And the 25 and the negative 25 end up canceling out. So then really, when I write this in something that's easy to anti-differentiate, I have the integral from 0 to 4 of 10 times the square root of y. That's going to be 10y to the 1/2 power minus y to the 1st power dy. All right, so now I'm ready to anti-differentiate. So the antiderivative of y to the 1/2 is going to be y to the 3/2. But then I have to multiply in front by 2/3, and then there's already a 10 there, right? So 10 times 2/3 y to the 3/2. And then the negative y is going to become negative 1/2 y squared. And I'm evaluating this from 0 to 4. So then I go ahead and I do the evaluation theorem. And I get pi times 10 times 2/3 is 20/3 times 4 to the 3/2 power minus 1/2 times 4 squared minus pi times, and then fortunately when I plug 0 in, I'm just going to get 0 for both of those terms. So I'm going to be able to just cross that part out. So now I just need to go ahead and simplify. So 4 to the 3/2 power, well, the square root of 4 is 2, and then 2 cubed is 8. And then 8 times 20/3 is going to be 160/3. And then 4 squared is 16 times negative 1/2 is going to be negative 8. And then if I turn 8 into thirds, that's going to be 24/3, right? So I end up with pi times 160 minus 24 over 3, which gives me 136 pi over 3 for my final answer.